This is a solution to problem number 4 from the online homework J on confidence intervals. This one's a little tricky because the decimal numbers are very small, and so it's easy to get lost in all the .000 stuff. So here's a version of it that's copied out with all the answers already there. But let's just go through where these numbers come from. First, we're asking about the point estimate, and we know that should be our p hat sample proportion, which is the number of successes, which is 31, divided by the total sample size, so 4,400. So right away we get some numbers that are very small. So this is 0.0070 rounded to 4 decimal places. I can probably even round it further than that if I find my calculator value. 0.00705, I think. And what I'm going to do here is just round these numbers off. I'm going to keep as many decimal places as I can because I'm really not sure about how big and small these numbers get. So I'm going to err on the side of being too precise. We know our standard error formula is this thing, so p times 1 minus p over n, all under the square root sign. And as usual, when we're doing a confidence interval problem, we don't actually know what p is, and so we use p hat instead of p in this formula. And so if I do that, I'll end up with, so the p hat is 0.000705, and the n is 4,400, like it was before. And so I put those values in here, 0.00705 times 1 minus 0.00705 divided by 4,400. And then depending on the kind of calculator you have, you might put all of that in and then hit the square root button, or you might have a calculator that shows the square root every step along the way. But either way, that's what you're going to put in, and you'll get the answer that's shown there, 0.00126, and I can give you that even more decimal places, 0.00126. I have 134. So if I keep all this rounding in there, then I can see I can make sure I can answer my question to as many decimal places as it says. Margin of error, this is the 95% confidence interval, and so margin of error is the magic z-score for 95% confidence, which is 1.96 times standard error. So I have to multiply the number that I just computed, this number here, with standard error. I'm going to multiply that by 1.96, and I'll get 0.002472. So that will be my margin of error. For the confidence interval, the two limits of the confidence interval, one will be the point estimate minus margin of error, and the other one will be point estimate plus margin of error. So in this case, and this is where it gets hard to keep your decimal places straight, but just be very careful. P hat was 0.00705. That was the answer from part A, minus margin of error is subtracting 0.002472. So that's the lower number for the confidence interval, and the upper number will be p hat 0.00705 plus margin of error 0.002472. So I'm taking my p hat, adding and subtracting margin of error, and that will give me the two values here. So, and every step along the way, it wants us to write these answers to 5 decimal places. And my recommendation is when you're trying to end up with 5 decimal places, then round your steps, your intermediate steps, round those off to 6 decimal places. So, so that's the process for a confidence interval. There were some questions on this one, I suspect, mostly because the numbers were so decimally that it's just easier to make a mistake. But the process is exactly the same. The 5-step process that we gave was find the point estimate, the standard error, the margin of error, find the 2 upper and lower limits of the confidence interval, and then state your conclusion in plain language. Here, the statement, you can see letter B down there says basically we're 95% sure that the true proportion is in between these two numbers in the confidence interval.